So, we were computing dt upon ds dot u, because dt upon ds is kg bar dot u. Okay. So, this will give us the vector kg, scalar kg. So, when you take dot product with u, the first term will become just simply d theta upon ds, and the remaining term we have written like this. So, next we will substitute the value of u from number 4 plus cos square theta into dt1 upon ds1 dot u is here minus sin theta t1 plus cos theta t2. Similarly, cos theta into sin theta dt1 upon ds2 dot minus sin theta t1 plus cos theta t2. Okay. So, we have come up to here. Okay. Next, plus cos theta sin theta dt2 upon ds1 dot minus sin theta into t1 plus cos theta into t2. So, the last term is plus sin square theta dt2 upon ds2 dot minus sin theta t1 plus cos theta t2. All right. So, now let us settle these terms one by one. So, starting from here, you see, you know one thing, that t1 is a unit vector. So, t1 dot t1 is 1. So, if you differentiate it, so on differentiation this will give you dt1 upon ds1 dot t1 plus same thing equal to 0. So, that means the first term when you take the dot product will give you 0. Similarly, over here this term will go off when you will take the dot product, and this term, second term from here will become 0. In the last relation, this cos theta term will be 0. So, this term will not contribute anything, they will be, dot product will be 0. Let us look at the remaining terms. So, the first one here is d theta upon ds plus you have then cos cube theta into dt1 upon ds1 dot t2. So, this is taken care of, cos cube theta. Now, come over here. So, this will be plus cos square theta into sin theta dt1 upon ds2 dot t2. So, this is also considered. Now, come over here, then you have a minus sign cos theta into sin square theta dt2 upon ds1 dot t1. So, this is done, and the last term is here. So, minus sin cube theta dt2 upon ds2 dot t1. I hope we have written all terms correctly. So, now look at those relation kg1 and kg2. dt1 over ds1 dot t2, the first one, the second one, this is kg1 cos cube theta, So, this is d theta upon ds plus cos cube theta into k g 1. dt 1 upon ds 2. Okay. Okay. So, this leave it, and then you have dt 2 upon ds 1 here also, d fourth term. So, I will write down this first. So, this and this I have written minus sin cube theta into dt 2 upon ds 1. There is a minus sign over here. So, I will put it plus. So, this is k g 2. Now, look at the remaining term. What can you do with these terms? Look here, T 1 dot T 2 is 0, T 1 dot T 2 is 0, and if I differentiate this relation, I will be getting d T 1 over d s 2. Okay. What s 2? Okay, d t. Okay, what you do? Don't write this. Okay. Something common from here. Okay, if I take cos theta sin theta common. Okay, cos theta sin theta common. Cos theta sin theta common between these two terms, dt 2 upon ds 1 is not there. So, that will become cos theta into dt 1 upon ds 2. I wanted to make them same, and this will become minus dt 2 over ds 1. Okay, I can do something with this also. Look here, T 2 dot T 1 is 0. So, you differentiate with respect to S 1. So, this will give me d T 2 upon d S 1 dot T 1 plus T 2 as it is d T 1 upon d S 1 dot T 2. This is 0. This tells me that d T 2 upon d S 1 dot T 1 is actually minus times d T 1 upon d S 1 dot T 2, and this is what d T 1 upon d S 1 dot T 1 is k g 1. So, this term will become k g 1. Okay. So, you rub it off. So, we had written up to where this term, and this term. Now, this I will write down first. So, this is minus times d T 2 over d S 1 is equal to d minus time this. So, it will become plus. So, plus cos theta sin square theta k g 1. So, this is taken care of. Okay. Similarly, this will be equal to d T 1 upon d T 2 upon d S 2, d T 2 upon d S 2 T 1. This will also be equal to k g 2. So, this is k g 2 plus or minus plus. So, this will become cos square theta into sin theta k g 2. So, this is also taken care of. So, all the terms have been taken care of. Now, we can write down our final result. I can rub off this part. You check it up whether this line is visible. Okay. So, this is equal to d theta upon ds plus, what are the terms of Kg1? This one and this one. Cos theta is common. So, this will be cos square theta plus sin square theta, which is 1. So, it will become Kg1 cos theta. So, cos theta into Kg1. Now, look at this term and this term together. So, sin theta is common between them. This will become sin square theta, this is cos square theta, Kg2 is common. So, it is simply Kg2. So, this proves the result. This is, and look at the left hand side. What is this? dt upon ds is Kg bar. So, Kg bar. So, this implies Kg bar dot u equal to this. Kg bar dot u is Kg. So, this is simply Kg. So, this proves the result. All right. So, Lioville's theorem is proved completely. Now, next thing that we have to discuss here is a geodesic, the idea of a geodesic. Thing is a geodesic. So, by definition, a geodesic on a surface is a curve whose geodesic curvature is 0. So, a geodesic on a surface is a curve whose geodesic curvature is 0. Now, you know that geodesic curvature Kg bar, if you remember fully, the curvature k of a curve on a surface is Kg bar plus Kn bar, and this we worked out, it is equal to gamma Kij dui over ds duj over ds plus d2 uk upon ds square into rk plus bij dui over ds duj over ds n. Now, if you look at the right hand side, you will notice that this is tangential to the surface, and therefore, it is the vector, it is the geodesic curvature vector Kg bar, and this quantity, this vector is Kn bar. This is the normal curvature vector and this is the geodesic curvature vector. If some curve is a geodesic, then this part must be 0. So, this means, so that is this vector equal to 0 means the scalar multiplying it must be 0, because these are non-zero vectors. So, and independent vectors as well. So, Kij dui upon ds duj upon ds plus d2 uk upon ds square equal to 0. So, this becomes the equation of a geodesic. So, this becomes the equation of a geodesic. In fact, it is not a single equation, because I j are dummy indices. So, there is some ovation I j, but k over here and over here is a free index. So, k varies from 1 to 2. So, these are in fact two equations. So, these are in fact two equations. So, there are two equations which together will represent a geodesic on a surface, but if you want a single equation of a geodesic, that can also be done. So, what we do to obtain a single equation, to obtain a single equation of a geodesic, we put du 1 upon ds equal to du 1 upon du 2 into du 2 over ds in the expression of which expression you remember, there is an expression for kg. That expression is under root g times determinant du 1 upon ds, then gamma 1 I j du I upon ds du j upon ds plus d 2 u 1 upon ds square, here du 2 upon ds, and then you have gamma 2 I j du I upon ds du j upon ds plus d 2 u 2 upon ds square. This is kg, and if I equate this to 0, that will give me kg equal to 0. So, we put du 1 upon ds equal to this much in this expression and equate it to 0 and equate it to 0. So, if I equate this expression equal to 0, that means I am putting kg equal to 0. The right side will be 0 if this determinant is 0, because under root g is not 0, surface is assumed to be regular. So, that means kg equal to 0 is equivalent to saying that this determinant is 0, that is kg equal to 0 is equivalent to the determinant equal to 0. Okay. And this means, or I can rewrite it, du 1 upon ds multiplied by gamma 2 I j du I over ds du j upon ds plus du 2 upon ds square, no, d 2 u 2 minus du 2 over ds into 1 I j gamma 1 I j du I upon ds du j upon ds plus d 2 u 1 upon ds square equal to 0. Okay. So, what we have to do? We have to just simplify this expression. So, or I can simplify it. So, 2 times 2 gamma 2 I j will run from 1 to 2. So, it will be 2 1 1 into du 1 upon ds whole square and this du1 upon ds is multiplying. So, it will become q. Okay. And then 2 times 212 du1 upon ds whole square into du2 upon ds, okay, plus 222, okay, du2 upon ds. So, du1 upon ds from outside into du2 upon ds whole square. All right. So, the first bracket is over. Similarly, the second bracket 1, yes, that is also there, this one is left. So, plus d2u2 upon ds square into du1 upon ds. Okay. So, now come to this bracket. So, minus 111 du1 upon ds whole square into du2 upon ds, and minus once again 2 times 112. So, du1 upon ds into du2 upon ds whole square, plus again minus 122, this will be du2 upon ds. So, du2 upon ds whole cube, and the last term is d2u1 upon ds square into du2 upon ds with minus sign. I hope we have written correctly. So, the next thing that we have to do, which I have mentioned here, you have to write down du1 upon ds as du1 upon du2 into du2 upon ds. So, replace everywhere du1 upon ds by this, and this equal to 0. All right. So, okay, there are too many terms, but anyway 211. So, this will become du1 upon du2 whole cube into du2 upon ds whole cube. Here also 2 times 212, this will become du1 upon ds du2 whole square into du2 upon ds whole cube. Over here 222 du1 upon du2 into du2 upon ds whole cube. Next is this. So, plus d2u2 upon ds square into du1 upon ds du2 sorry du2 into du2 upon ds. So, we have written down term up to here. Next, similarly, we will be writing down here. So, minus 111 du1 upon du2 whole square into du2 upon ds whole cube minus 2 times 112 du1 upon du2 into du2 upon ds whole cube and this second last term is minus 1 to 2 du 1, this you keep as it is, du 2 upon ds whole cube minus, this is to be resolved, we can see what it becomes. You have d2 u1 upon ds2, that I can write down as d by ds of du1 upon ds, and this du1 upon ds I will write down as du1 upon du2 into du2 upon ds. And now by part it will be d2 u1 upon du2 square into du2 upon ds whole square plus du1 upon du2 into d2 u2 upon ds2. So, this term will be this much du2 upon ds, where it is du2 upon ds, this one, this will become cube and minus sign will come. So, then I will be having a minus sign d2 u1 upon du2 square था, so du2 square into du2 upon ds whole cube because of this, and then once again minus du1 upon du2 du2 upon ds d2 u2 sorry d2 u2 upon ds square into du2 over ds. Perhaps one of the term will cancel out from where this will cancel, no, we are here 1 2 3 4th. Okay. Yeah. Yes. Now, you see in the remaining term what is happening is du2 over ds whole cube is coming everywhere, you can see it. So, we can remove du2 upon ds whole cube from here. From here you take it common, the right side is 0. So, you forget about it. So, du2 over ds is everywhere. Okay, so, that is good. Okay. Now, I can combine the remaining terms. So, you have to start from here, second order term first. Okay. Okay, so minus d2 u1, okay, we will do plus later, minus d2 u1 upon du2 square. So, this term has been taken. Now, I can start from here, cube term is only one, there is no other cube term. So, plus 211 into du1 upon du2 whole cube. So, this is also taken. and then you have square term. Where are they? These two terms are square, so you minus I will take common, so it becomes 1 1 1 1 and then plus 2 1 2. Into du1 over du2 square. Only one term is a square term? Somewhere, no, it should be, there were two perhaps. Somewhere 2 1 2. 2 1 2 is where? Here. Okay. And where is this one? Where is 1 1 1? Yeah, and there should be one more. Let me see if you have, there is only one square term. There must be two, 1 1 1 and 2 1. Perhaps from here 2 1 2, where it is? So something is, so we have made a mistake here. So these are the two square terms, one is 1 1 1 and the other one is 2 times 2 1 2. Both are, this is positive or negative? Positive. So I must put a negative sign. So minus minus plus. Okay. All right. This was negative, minus I have taken common. So I have taken care of this one. And okay, okay. This one I have taken, and where is the other one? Above one, this one. No, no. Where is this term? We have missed this one term. Okay. So now next is plus. I will look at the term of degree 1. So these are the two terms of degree 1. So plus 2 2 2 minus 2 1 2 1 1 2 into du1 upon du2. So these two terms are also gone. And the last one is minus 1 2 2. This is equal to 0. If you don't like a minus sign over here, you multiply it throughout by minus. So this will become d2u1 upon du2 square, and then it will become minus 211 into du1 upon du2 whole square. This you make at plus whole cube, I am sorry. So this is 111 minus 2 212 du1 upon du2 whole square, and then the last one is negative, second last, 222 minus 2 times 112 du1 over du2, and then plus 1 to 2 equal to 0. So this is a single equation of a geodesic, which is in fact a differential equation. So this differential equation of order 2 represents a geodesic. This single equation, this single differential equation of second order of second order is the equation of represents a geodesic. A geodesic. Yes, geodesic on a surface. All right. Now, let us see what do you deduce from this. In fact, we can deduce the existence and uniqueness of a geodesic if I am given a point on a surface with coordinates u1, u2, and if I know a direction du1 upon du2, then I can construct higher order derivative, second order derivative also, and this differential equation, if I know the initial condition, then I know a geodesic. So, in other words, if you are given a point and a direction, then there exists a unique geodesic along this curve. Is it right? So, this in fact tells you a theorem. So, the situation is like this: on a surface, suppose I start from here at this point P and I think of this direction, then there will be a unique geodesic going along this direction. Okay, so, this gives rise a theorem. So, hence we deduce, let me write down, hence we deduce the following theorem. In every direction, given a point, in fact, you have to start from some point. Given a point P with coordinates u1, u2 and a direction du1 upon du2, there exists given a point P on a surface of class how much? C2, because you need at least second order derivative of class C2 and a direction this at P, there exists a unique geodesic. In other words, in every direction there exists a unique geodesic. In other words, in every direction there exists a unique geodesic.
When you want to find the geodesic of some curve on surface, we have to solve this equation.
Yes, this guarantees, you do not need to solve this equation. This equation just guarantees the existence and uniqueness of a geodesic. In fact, you can work out that equation, the original differential equation, which are in fact two differential equations. That will be easier. In every direction.
So we have done the proof of this theorem.
Yes,
Somebody asked this theorem, we have to prove this.
you have to prove this. So,
Somebody asked that find a geodesic of some particular, so how to proceed?
so you give me a direction. Give me a direction and an initial point, I will give you the geodesic. It is like this. Suppose I give you 2 points there will be many curves from here to here, but the geodesic is the is a curve whose differential equation is this. Okay. So, in order to know this curve, you need to know its direction. Okay. So, if initial direction is known, you know direction along the entire curve. There exists, in other words, in every direction there exists a unique geodesic. Geodesic is always a curve of shortest distance between 2 points. So, minimal with geodesic I do not think we should use. So, should I stop at this point? How much time I have taken?